Hello everyone, and welcome back to the channel. Today, we're diving deep into a topic that keeps our homes safe and our gadgets running, but one we often take for granted: the humble circuit breaker. What exactly is that little switch in the metal box on your wall? How does it protect you from electrical disasters? Let's flip the switch and find out. To really understand what a circuit breaker does, we first need a quick refresher on how electricity works in our homes. Think of your home's wiring as a network of roads and electricity as the traffic. You have a power source, like the utility company, that sends electricity to your house. This electricity flows through wires to your outlets and light fixtures, powering everything from your TV to your toaster. This complete path is called a circuit. Now, just like roads have speed limits and capacity, your home's circuits are designed to handle a specific amount of electrical current, which is measured in amperes, or amps. A typical lighting circuit might be rated for 15 amps, while a circuit for a heavy-duty appliance like an electric dryer might be rated for 30 amps. Everything works perfectly as long as the electrical traffic stays within these limits. But what happens when things go wrong? This is where the two main villains of our story come in: overloads and short circuits. Let's talk about overloads first. Overload is exactly what it sounds like. You're asking a circuit to handle more electricity than it is designed for. Imagine plugging a power strip into a single outlet and then connecting your computer, your monitor, a printer, a space heater, and your phone charger all at once. Each of these devices draws current. Add them all up, and you might exceed the 15 or 20 amps that the circuit is rated for. When this happens, the wires start to heat up. It's like a traffic jam on the electrical highway. The more current, the more friction between the electrons, and the more heat is generated. If left unchecked, this heat can become so intense that it melts the plastic insulation around the wires. This can lead to a fire, which is obviously something we want to avoid. The second villain is the short circuit. This is a much more dramatic and dangerous event. A short circuit happens when the normal path of the electricity is interrupted, and the current finds a shortcut. Usually, this occurs when a hot wire, the one carrying the current, touches a neutral wire or a ground wire. Why is this so bad? Remember Ohm's law from science class? It tells us that current is equal to voltage divided by resistance. In a normal circuit, your appliances provide resistance, which controls the flow of electricity. But in a short circuit, the resistance drops to almost zero. This means the current can surge to incredibly high levels, hundreds or even thousands of times the normal amount, in just a fraction of a second. This massive surge of energy creates an intense burst of heat and a bright, dangerous arc flash. It's more than enough to start a fire instantly or cause an explosion. So, how do we protect ourselves from these electrical bad guys? In the old days, we used fuses. A fuse is a simple device with a small piece of wire inside that is designed to melt and break the circuit if the current gets too high. It's a one and done solution. Once a fuse blows, you have to replace it. This is where the modern circuit breaker comes in as a major upgrade. A circuit breaker is essentially a reusable, automatic switch. It does the same job as a fuse. It interrupts the circuit when there is too much current, but it does so without self-destructing. You can just reset it. Let's peek inside a typical thermomagnetic circuit breaker, the kind you most likely have at home. It has two different trip mechanisms to handle both overloads and short circuits. First, let's look at the overload protection. Inside the breaker, there's a small, clever component called a bimetallic strip. This is made of two different types of metal, like steel and brass, bonded together. These two metals expand at different rates when they get hot. When your circuit is overloaded, the excess current flowing through this strip causes it to heat up. As it heats, one metal expands more than the other, causing the strip to bend. This bending action is calibrated so that once it reaches a certain point, it physically trips a latch, releasing a spring-loaded switch and breaking the circuit. The power is cut off, and the danger of fire from overheating is averted. This process is relatively slow. It's designed to allow for small, temporary surges in current, like when a motor in your air conditioner starts up. It won't trip instantly but will react if the overload condition persists for more than a few seconds or minutes, which is what happens when you have too many things plugged in. But what about the violent, instantaneous danger of a short circuit? The bimetallic strip is too slow to react to that. For short circuits, we need a different mechanism. This is the magnetic part of the thermal-magnetic breaker. Inside the breaker, there's also an electromagnet, which is basically a coil of wire. When a short circuit occurs, that massive surge of current flows through this coil. This instantly creates a very strong magnetic field. This magnetic field pulls on a metal armature, which is a small lever. The movement of this armature is what trips the same latch that the bimetallic strip would, but it does so almost instantly. We're talking milliseconds. This incredible speed is crucial for stopping the massive energy of a short circuit before it can cause a fire or an arc flash explosion. So, to summarize, the thermal part, the bimetallic strip, protects against the slow burn danger of overloads. The magnetic part, the electromagnet, protects against the fast, explosive danger of short circuits. Together, they provide comprehensive protection for your home's wiring. When a breaker trips, the switch on the front will usually move to a tripped position, often halfway between on and off. To reset it, you typically have to push the switch fully to the off position first, and then back to on. This re-engages the internal mechanism. Now, before you go and reset a tripped breaker, it's really important to figure out why it tripped in the first place. If it was a simple overload because you ran the microwave and the toaster at the same time, you can unplug one of them and then safely reset the breaker. But if a breaker trips repeatedly, or if you reset it and it immediately trips again, that's a sign of a more serious problem, possibly a short circuit somewhere in the wiring or in an appliance. In that situation, don't just keep resetting it. It's time to call a licensed electrician. In recent years, we've seen the development of even more advanced circuit breakers. You might have heard of AFCI and GFCI breakers. GFCI stands for Ground Fault Circuit Interrupter. These are designed to protect people from electric shock. A GFCI constantly monitors the amount of current going out on the hot wire and coming back on the neutral wire. In a normal circuit, these two amounts should be exactly the same. But if you were to, say, touch a faulty appliance while also being grounded, some of that electricity would flow through your body to the ground. The GFCI would detect this tiny imbalance, as little as 5 milliamps, and shut off the power in a fraction of a second, potentially saving your life. That's why they're required in places like bathrooms, kitchens, and outdoors, where the risk of shock is higher. AFCI stands for Arc Fault Circuit Interrupter. These are designed to prevent fires caused by arc faults. An arc fault is a dangerous electrical arc created by damaged, loose, or corroded wiring. These arcs might not draw enough current to trip a standard breaker's overload or short circuit protection, but they can generate intense heat, like a tiny welding arc, that can easily ignite nearby materials like wood or insulation. An AFCI breaker has sophisticated electronics that can detect the unique electrical signature of a dangerous arc and shut the power down before a fire can start. So, from the simple fuse to the complex AFCI breaker, The evolution of circuit protection has been all about making our homes and our lives safer. These devices are the silent guardians of our electrical system, constantly watching for trouble and ready to spring into action in the blink of an eye. The next time you see that panel of switches on your wall, you'll know it's not just a simple on-off box. It's a sophisticated piece of engineering, with both thermal and magnetic systems working together to protect you from overloads and short circuits. It is a testament to how we've learned to harness the incredible power of electricity, while still respecting its potential danger. I hope this deep dive into the world of circuit breakers has been illuminating. It is a fascinating blend of simple physics and clever engineering that keeps us all safe every single day. If you found this video helpful, please give it a thumbs up and consider subscribing for more content like this. And as always, if you have any questions, drop them in the comments below. Thanks for watching, and we'll see you in the next one.